We are continuing with our scalar, and now we're asked to analyze using the scalar multiplication. We're given a vector right here and its components of change in x and change in y, and its magnitude is 6 units long. Okay, fill in the blanks to complete the following sentences. Okay, so it looks like W, so vector W is equal to 2 times vector v. Okay, so notice that it's like a 2 has been distributed to each part here. Okay, well, the magnitude is 6 on vector v. So 2 times, and we would just multiply it. So 2 times the magnitude of vector v then would just be 2 times 6. And 2 times 6 is 12. So this one looks like it's a 12 here. Okay. And then vector z, notice that you have it's like a coefficient here, but that's our scalar multiplier. It's our scalar right there. So vector z here is equal to, looks like it has that scalar effect of negative 2/3. It's switching directions and then reducing it by 2/3 of the original vector v. Okay, and then we're basically asked to examine its magnitude. So its magnitude of vector z is going to be equal to negative 2/3 of the magnitude on v, which is 6. And then we just need to remember that magnitude is a distance idea, and distance is always positive. So you can look at these absolute value, magnitude bars, kind of like absolute value bars. That's how I kind of think of them too. So your answer is always going to be some sort of absolute value answer, or it's going to be a distance idea. So negative 2/3 times our magnitude of v is 6, which is equal to the 3 and the 6 reduce into 2. So it's the absolute value of negative 2 times 2, which is equal to absolute value of negative 4, which is equal to positive 4. All right. So I found out that magnitude of z is positive 4. And then it wants to match each vector defined above to a vector that could be its equivalent. Okay, so let me just go ahead and fill these in so we can kind of see a little bit better. So this is a 12. Got 4 on this one. And now we can start doing the analyzation here. So it's really important to kind of recognize and remember that this one changed directions. It had that negative right there as a scalar multiplier. A negative as a scalar switches the direction on the vector. So right away, the only one that switched direction is this one right here. So that one would match to vector z, and then we would just kind of look at which one's bigger and smaller. So this vector w is longer, L-O-N-G-E-R. Boy, my letters were missing tops there. Longer. This one's longer than this one right here, and this one's shorter. Shorter. Just do cursive. All right. And then this one switched directions like we talked about. So let's go ahead and see how we did. So I like doing the switch direction first. So the W, what was W, is the Z, this Z switch direction. Also notice this is the smallest vector, so it should be the smallest length here. And let's take a look at these two. W is the longest one, and V is the medium one. So it's just kind of good to remind yourself and link together which one's which. Got it.